Hello, good morning, my dear students, and welcome to the world of electronics. Our lesson for today is taken from Lesson 1 of Module 2 under ALX 111, which is Electronic Devices, Instruments, and Circuits. The lesson tackles about multimeters, their uses, safety precautions, and proper maintenance. Basically, there are two types of multimeter. We have the analog multimeter and the digital multimeter. You might say, class, why should I use analog multimeter since I have digital multimeter, which is in consonance with the new era of technology today? For your information, class, there are things or situations which an analog multimeter can do and a digital multimeter can't. So it is still very important for us to study analog multimeter. Our activity will start with the discussion of analog multimeter. Basically, there are important parts of an analog multimeter. First, we have the test prods, or test leads, or test probes. Some multimeters, the test prods or the test probes are separated from the housing of the multimeter itself. We have heard the positive test prod and the negative test prod. It composes of a banana plug which is inserted to the respective banana jack. It is inserted here to the red color, which is positive, whereas the black test prod or test probe is inserted to the common or negative side of the multimeter. Then, the other ends of these test prods are the tip, which is used to inject or connect to the test points of the circuit, just like this. Or, the tip of these test prods are usually connected to the two terminals of the electronic components such as resistor, transistors, ECR, and other electronic components. Then we have the range selector switch or range selector. We have here. You may just rotate this clockwise or counterclockwise to choose or select the ranges that you are going to use. So, there are actually meters here in this multimeter. That's the reason why it is called multimeter, because it composes of several meters such as ohmmeter. In ohmmeter, there are ohmmeter ranges. We have heard it times 1 ohm, times 10 ohm, times 100 ohms, times 1 kilo ohm, and times 10 kilo ohms for this type of multimeter. Weller brand. Whereas we have the other brand, which is Sanwa, made in Japan. There are actually ohmmeter ranges also, such as times 1 ohm, times 10 ohm, times 100 ohms, times 1 kilo ohm, and times 100 kilo ohms. So this ohmmeter has the capability of measuring higher resistance compared to this analog, since the highest range here is only times 10K, and we have heard times 100K. So you are going to read the uppermost meter scale. We have heard the uppermost meter scale for ohmmeter whenever that your range selector switch is positioned to any of these ranges. So you are going to read this meter scale here. Then we have also here the DC voltmeter. It has ranges, voltmeter ranges, that has 0.1 volt up to 1000 volts. Then you are going to read this meter scale here using this value. Then we have the DC ammeter. It has 4 ammeter ranges for measuring DC current. We have the lowest range, 50 microamperes, 2.5 milliampere, 25 milliamperes, and 250 milliamperes as the highest range. Then still you have to use this meter scale. This meter scale is for the DC voltmeter and the DC ammeter. The red color meter scale is used exclusively for the AC voltmeter, measuring voltages which is AC. The highest range is 1000 volts and the lowest range is 10 volts. Then we still have another meter here, the decibel meter. We are going to use this meter scale here. This is used to measure the signal strength of an AC signal. Let us say the audio signal of a certain amplifier. You may just set this to 10, which is 22 decibel. Then you have to read this meter scale. Then we have also the meter for battery testing, 1.5 volts battery tester. So you are going to use this meter scale here. If it is red, meaning to say the battery is bad, meaning the voltage is already low and as well as the current. But if the pointer position to this level, it is good. Okay. Those are the meters that this multimeter is equipped. Then, we have here the 06 screw. 06 screw class is very important during testing and measuring because it entails the position of the deflection pointer. During at rest, when the tester is not yet used, the position of this deflection pointer should be set to the 0 level here or infinite position for the ohmmeter to have an accurate reading. Because if it is advanced or below the 0 scale, there is a wrong measurement. There is a wrong reading of the value. So you have to set it using a minus screwdriver. Just insert the minus screwdriver to the slotted head here. In such a way the deflection pointer moves. If the slotted head is rotated counterclockwise, the pointer moves forward. If it is clockwise, the pointer moves lower or left side. So it should be set to 0 scale here. It is now positioned to 0 scale. That is before the multimeter is used. You have to check first whether the position of this deflection pointer is at 0 scale or infinite position of the ohmmeter scale, because it may cause wrong reading for that. No? Okay. That's the importance of the 06 screw for all meters. Then we have here the 0 ohm adjuster. We have here. The 0 ohm adjuster is exclusively used for the ohmmeter alone. Whenever that you are using the ohmmeter, let us say you are using the times 10 ohm range, for example, for measuring the resistance of a certain component. So before you use the ohmmeter, you have to short first the two tips of the test rod. When you short the two test rods, the pointer deflects. Then, it is not actually set to 0. So you have to set that to 0 ohm before you attempt to measure the resistance of a certain component. Or, when you change it to times 100K or 10K, again, before you measure a certain component, again and again you have to short the test rods. Then you see that it is not positioned to 0 ohm. Again, you have to set it to 0 ohm. When you go back to times 1 times 10 ohms, again, the position of the pointer is not at 0 ohm. Again and again, you have to set it to 0 ohm to have an accurate reading. So whenever that you are changing the position of the ohmmeter ranges, it is very important to set it first to 0 ohm using the 0 ohm adjuster. No? Okay, that's the importance of the 0 ohm adjuster. 0 ohm adjuster can't be used for setting the voltmeter and ammeter, because when you are at the voltmeter ranges, then try to short the test rods, it won't deflect, because shorting of two test rods is used only for the ohmmeter. Okay? Then, we have heard the deflection pointer or the deflection needle. The deflection needle or deflection pointer is actually assembled to the assembly of this armature. It is connected actually to the moving coil. No? Then that moving coil is surrounded with magnet. Surrounded with magnet. Okay? Whenever current flows, the pointer deflects. Okay? It may become from the battery itself during ohmmeter, or from the current of a certain electronic circuit like television set, digital TV, DVD player. Whenever you are measuring the voltages there, current flows and it causes the movement of the pointer. Okay. Then, we have heard the meter scales actually under the meter movement. No? Okay. That's all for the basic parts of the analog multimeter. Now, let us come to the reading of this ohmmeter scale, the uppermost scale among the meters here. That is when you are using the ohmmeter ranges for measuring the resistances of a certain component or certain circuit in ohms, kilo ohms, mega ohms, giga ohms, or possibly tera ohms. But remember that the highest resistance that this ohmmeter could measure is up to 2 kilo ohms times 10 kilo ohms is 20 mega ohms. That is the highest resistance that this ohmmeter can measure. Okay? Unlike this multimeter, which is made of Sanwa brand, the high strength is times 100K. Times 2K is how much? 200 mega ohms. No? The highest resistance that this multitester or ohmmeter could measure is up to 200 mega ohms. Okay. So, at first, let us familiarize the reading of the meter scale here. Okay? We have here, you can notice, class, that among the meter scale here, only ohmmeter is different. Because the lowest value is here, at the rightmost portion, and the highest resistance is at the leftmost portion. Unlike the voltmeter and ammeter DC meter scale, the highest value is here, and the lowest is here, since the zero is here. Also with the AC voltmeter, red color, the highest is over here, and the lowest is over here. And you can also notice that the calibration or ang halaga ng bawat guhit dito is different. From 0 to 2, the calibration is 0.2 volts. Then from 2 to 10, the calibration is 0.5 volts. Then from 10 to 20, the calibration is 1 ohm. The calibration from 20 to 30 is 2 ohms. Then from 30 to 50, the calibration is, this is 40, this is 2. 32, 34, 36, 38, 40, di ba? So, it is a nonlinear scale since the calibration is different. Unlike the voltmeter and ohmmeter scale here. Okay. So, in using ohmmeter, it is very important for us to familiarize the value here. So, when you are using ohmmeter, you have to read this meter scale here. This should be 1 ohm, 2 ohms, 5 ohms, 10 ohms, 20 ohms, 30 ohms, 50 ohms, 100 ohms, 200 ohms, 500 ohms, 1 kilo ohm or 1000 ohms, 2 kilo ohms or 2000 ohms. Then we have here a Lisa 8 or infinity, meaning to say the resistance is very high and it could no longer be measured. Just like when you are measuring the air using times 10K, short per the test rods, and set it to 0 ohm using this ohmmeter adjuster. Try to measure the air. The diffraction pointer doesn't deflect. Or the plastic, the glass. The resistance is very high. It is called infinity. Okay? So, whatever you're reading here should be multiplied to the ranges. That's why it is times 1, meaning it is a multiplier. Times 1 ohm, times 10 ohms, times 100 ohms, times 1k ohm or times 1000 ohms, times 10 kilo ohms or times 10,000 ohms. So, if the pointer position here, we have here, closer. It is 10 ohms. Times 1 ohm, it is 10 ohms. But if it is positioned to times 10 ohms range, 10 ohms times 10 ohms here as a multiplier or the ohmmeter range is 100 ohms. But if you are at times 100 ohms, 10 ohms times 100 ohms is 1000 ohms or 1 k ohm. If your range selector switch is positioned to times 1 k ohm, then the pointer is positioned at that level or meter scale. 10 ohms times 1 k ohm is 10 kilo ohms or 10,000 ohms. If you are using the highest range times 10 kilo ohm or 10 kilo ohms, so 10 ohms times 10 kilo ohms is what? 100 kilo ohms or 100,000 ohms. That is the way how you read the meter scale. So whatever you're reading here should be multiplied to the ohmmeter ranges you are using. So, those are all about the major divisions, yung mga matataas na guhit dito. How about this from 0 to 2? Or from 0 to 1? What is the calibration? So, we could analyze that this is 0.2, 0.4 ohms, 0.5 ohms, 0.2 ohms, sorry, 0.4 ohms, 0.6 ohms, 0.8 ohms, then 1 ohm, 1.2 ohm, 1.4 ohms, 1.6 ohms, 1.8 ohms, 2 ohms. Then this is 2.5 ohms, 3 ohms, 3.5 ohms, 4 ohms, 4.5 ohms, 5 ohms, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5 ohms, 10 ohms. Then, this is 11 ohm, 12 ohm, 13 ohms, 14 ohms, then 15 ohms. This major division or mataas na guhit with no value is 15 actually because between 10 and 20 ohms is 15. We have here the 16, 17, 18, 19, 20. Then 22 ohms, 24 ohms, 26 ohms, 28 ohms, 30 ohms.
So this is 40. Between 30 ohms and 50 ohms is 40. So we could analyze that this is 32 ohms, 34 ohms, 36 ohms, 38 ohms, 40. 42 ohms, 44 ohms, 46 ohms, 48 ohms, 50. Then 55 ohms, 60 ohms, 65 ohms, 70 ohms, 75 ohms, 80 ohms, 85 ohms, 90 ohms, 95 ohms, 100 ohms. Then, the calibrations here is 20 ohms. So, 120, 140, 160, 180, 200 ohms. Then, here there is a minor division or medyo maliit na guhit. This is 250 ohms, 300 ohms, 400 ohms, 500 ohms. Then, 1 kilo ohm or 1000 ohms, 2 kilo ohms. So, those are the way how we read. But, with this, between this portion here, so this is 0.6 and 0.8 is, between 0.6 ohms and 0.8 ohms is 0.7 ohms. Okay? Just analyze that between the two divisions is half of the calibration. Okay? So, meaning to say, there is a proper use of these ohmmeter ranges. When you are using times 1 ohm, meaning to say that the lowest resistance that could be measured is 0.2 ohms because this is 0.2 ohm. Times 1 ohm is 0.2 ohms. And the highest resistance that could be measured is only 2 kilo ohms. So remember that when using this times 1 ohm, see to it that the resistance that you are going to measure is somewhere at these ranges. 0.2 ohms and 2000 ohms or 2 kilo ohms. But when you are using times 10 ohms, the lowest range here is 0.2 ohm, di ba? 0.2 ohm. 0.2 ohms times 10 ohms is 2 ohms as the lowest resistance that this range can measure. Then the highest resistance should be 2K. 2K times 10 ohms is 20 kilo ohms or 20,000 ohms. Then, when you are using times 100 ohms, so 0.2 times 100 is 20 ohms. That is the lowest resistance. Then the highest is 2K times 100 is what? 200 kilo ohms. 1 kilo ohm range. Then 2K times 1K is 2 mega ohms. Because 1K is 1000 times 2K or 2000. 1000 times 2000 is 2 million ohms or 2 mega ohms. Then the highest range here is times 10K. 0.2 times 10K is how much? That is 2 kilo ohms as the lowest range, and the highest is 2K times 10K is 20 mega ohms. Unlike this Sanwa brand, that the highest range here is times 100K, then the same meter scale for both multimeters, 2K times 100K is 200 mega ohms for this type of ohmmeter, Sanwa brand. Okay. What should be the proper use? So, when you are measuring, for example, this one, resistor. No, resistor with a resistance. Then, try to use times 1 ohm. At first, times 1 ohm, the range selector switch is positioned to times 1. So, before you attempt to measure the resistance of this resistor, you have to set first or short first the two test rods. Usually the pointer deflects. Then, set it to 0 ohm at first using the 0 ohm adjuster. Then, measure. So, this is the way how you measure the resistance. The other test rod is connected to the terminal of the resistor being held by these fingers, while the other one should not be connected. Huh? Okay? It deflects using times 10 ohms. So the pointer is positioned here, somewhere here. Times 1. You are using times 1. Then, the pointer deflects. Okay? It is somewhere here. It is somewhere here. So, you are using times 1 ohm. Remember, times 1 ohm. So, this is 30, 40. So, between 40 ohms and 42 ohms is somewhere at 41 ohms. 41 ohms. Okay? Because when you are using times 10 kilo ohm range, short again, it is prods. So, the pointer is positioned to almost 0 ohm. So, that is very hard for us to read. And there is no accurate reading in that case because it will be very hard for you to read since we are using analog multimeter. So, remember that again and again, before you attempt to measure the resistance using another one, you have to set it to 0 ohm. Huh? Okay? How about use again another resistance here. Let us try this one using times 10 kilo ohms. So the pointer deflects at 0 ohm almost. 0 ohm almost. Meaning to say, you are using the wrong range. You are using the wrong range of an ohmmeter. So, select or choose an ohmmeter ranges wherein the pointer is positioned to almost at the middle scale. Because you can have an accurate reading, an easy reading, when the pointer deflects at almost middle scale. So you might think na there is a defect in this ohmmeter. The defect now is you because you're using the wrong range. So, why not try to use times 100 ohms? Again, short it is prods. Set it to 0 ohm using the 0 ohm adjuster. Then, this should be the way. So, your hands should not be connected to the two terminals because your body contains resistance. So, it can shunt or parallel to the resistance of this resistor. The resistance of your body and the resistance of your resistor are connected in parallel. Or it may cause different output resistance in that case. So, the other hand should not be connected. It should be like this. No? Okay? So, again, it is almost 0 ohm. Why not try the lowest range here? Lowest range. Again, set it to 0 ohm. Then, there's something wrong with this. Actually, the resistance here is 1.5 ohms. Because if you are using digital multimeter, here, set it to 0 ohm, yellow color, 0. You can tell nga it is at ohmmeter because the unit here is mega ohms. You can actually select volts, that is ohms. Okay, try. The reading here is 2 ohms or 1.6 ohms. Very low resistance. The colors here are brown, green, Gold, that is 1.5 ohms, decoded value of this resistor. But there is a little difference when you measure that one to the actual ohmmeter. Because remember that there is tolerance. That is why we have here the 5% tolerance. There might be deviation of the actual resistance, no? Okay. That's the the advantage of using digital multimeter, because the resistance is displayed digitally on the screen. Whereas here, we are only up to estimation. There is no accurate reading here. The only disadvantage of using ohmmeter, because it delays the display of the numeric value here. Just like a while ago, di ba? It takes a little time before the final resistance is displayed on the screen. That is only the main disadvantage. But it is very accurate. Okay? So for the maintenance and safety precautions here, let us take into account the proper position. The proper position of the tester or multimeter. It should be inclined position or prone position. That is the correct way. Because if it is standing position, the pointer is different from the inclined position or prone position. When it is standing position, the resistance decreases or the value decreases. Let us say 11 ohms. When it is standing, it is 10 ohms. So, the pointer moves lower. No? It is going to the left side portion. So, it should be inclined or prone position. So, the reading there is accurate. There is proper position of the deflection pointer. Then, of course, a multimeter should not be put close to a certain magnet because it can affect the reading. Or it might cause a permanent damage of the meter movement, because the meter movement here is composed of a moving coil and a magnet. So, it can affect the strength of the magnetic field of the permanent magnet here. Then, it may cause wrong reading because it controls the movement of the pointer caused by the magnetic field of a nearby magnet. No? So, it should be far from a certain magnet. Then, when you read the meter scale, it should be frontal. Your eye should be perpendicular to the pointer. 90 degrees. Perpendicular. It should not be sidewise. Left side or right side. It may cause wrong reading. Because if it is here, instead of 20 ohms, when you are at perpendicular to the pointer or meter scale, but here it is 21 ohms. Or when you are at here at the right side, it is 19 ohms. So the proper reading should be perpendicular. Your eyes should be perpendicular to the meter scale or to the pointer. Okay? Then, use proper ranges, of course. Or, after the tester is used, the position of the range selector switch should be positioned to off position. We have here the off position. Here. To avoid power consumption of the battery. Because remember, there is an external battery inside, which is used for the ohmmeter alone. Because when you are at here, ohmmeter ranges, there is a power consumption. Because actually, there is a shunt resistor. Although you are not shorting the two test pads, there is still a little amount of power consumption because of the shunt resistor. No? The shunt resistor will consume current from the battery. So, it should be at turn off position. Or, another reason for setting the range selector switch at opposition is to avoid damage. For example, meron kang anak or mga kaibigan na walang kaalaman tungkol sa paggamit ng tester. it happens that they try to test or connect the two test rods to a certain circuit, to a certain outlet here. Then, that was positioned here at the ohmmeter, or positioned at the ammeter, or positioned to the lower range of the voltmeter. It will cause internal damages inside the multimeter. That is one of the reasons why this range selector switch is positioned to opposition. Also to avoid power consumption of the battery, so that your battery will last longer. There is power consumption whenever you are at the ohmmeter ranges because of the shunt resistor. Okay? What else? Iwasang mabagsak ang multimeter sa floor. It will cause permanent damage because the meter movement is very delicate. There is a deviation or inclination of the movement. The moving coil, it will be tilted. So, magkakaroon ng mga disarrangement ng moving coil doon sa magnet. So, it may cause wrong reading na. So, or, once it falls, magkakaroon ng walang proper precision ng meter scale. Kaya nga, there's a need of setting the zero set screw here. Because once it falls down, it might cause wrong position of the deflection pointer. So, that's the reason why you should check first the position of the deflection pointer, whether it is at zero scale or infinite position of this ohmmeter scale before you use it. It might cause wrong reading. So, you have to set it using zero set screw here. Zero set screw. Okay? It moves when you rotate this zero set screw here. It should be set first to 0 ohm. Or zero scale here. Or infinite position for the ohmmeter. Okay? No? So, iwasang mabagsak ang multimeter natin para maiwasan yung permanent damage. Okay? What else, class? Okay? Again and again, use appropriate ohmmeter ranges when you are measuring the resistances of a certain component or circuit. See to it that the pointer is positioned at almost middle scale. You can get there the most accurate reading and the easiest way of reading the meter scale, because if the pointer is positioned over here or over here, that will be very difficult for you to read and it might cause wrong reading for that case. Because unlike the digital multimeter that will always provide accurate reading, since the value is displayed numerically using this screen. No? There is no parallax error. When your eyes are not positioned to the frontal position, or your eyes are not at the perpendicular to the meter screen or deflection pointer of a certain analog, so it can cause wrong reading. We call it parallax error. There is no parallax error with the digital multimeter. Even though you are at the left side or the right side, since there is no pointer, the value is displayed numerically, displayed on the screen. So there is no parallax error. So that is the advantage of using digital multimeter actually. Okay? By next meeting class, sa susunod na pagkikita natin, ay tatalakayin natin ang voltmeter AC at voltmeter DC using this meter scale. And here, also the ammeter scale. So huwag niyong kakaligtaan. By tomorrow, I will be discussing again another topic regarding multimeters. Okay, thank you my dear students, and so long.